is we have to make up some antibiotics, and we want to have 10 milliliter of 100 milligram per milliliter ampicillin solution. Ampicillin solution. What do I need to do? There are no trick questions, by the way. And I know that when I did projects, some of the students already found that a little bit challenging. So what do I need to do?
Times the 100 by 10. Right. Because if it's 100 mix in 1 ml, 10 ml.
So you say 100 milligrams per milliliter, that is in 1 milliliter. And we just simply times it by 10 because we want 10 milliliter.
Yeah.
Right? Gives you?
1,000 mg, which is
1 gram. Absolutely right. That was simple, huh? So you just say what's in 1 milliliter and what do I want? 10 milliliter, times it by that amount. That was almost too simple. Don't want to insult you. Okay. I want to have 150 milliliter of, say, 0.2 molar solution of a substance, and the molecular mass of this is 180 grams per mole. How much do I have to weigh in? Any suggestions? How much do we have to weigh in? I'll give you a couple of minutes to think about a strategy, how you would do that. That's the way that you probably are most familiar with, and then I show you a shortcut. Okay, we want to make 0.2 molar. First question, what does 0.2 molar mean? What does this capital M indicate? Molar, obviously. Moles per liter, thank you. So we have 0.2 moles per liter. That's a good starting point. We know something. We know that if we take 180 grams and put that into 1 liter, this gives us 180 gram is the equivalent of 1 mole. That's from this one here, from the 180 gram per mole. So if we take these 180 grams, put that into 1 liter, we would get a 1 molar solution. Yeah, does that make sense? But we don't want a 1 molar solution, and we don't want a liter. So, if I want, say, a 0.1 molar solution, just for argument's sake, how many grams would I have to use? 18. So 18 grams in 1 liter gives me a 0.1 molar solution. Yeah? Actually, I don't want a 0.1 molar solution. I want a 0.2 molar solution. How much would I have to use? I would have to use 36 grams in 1 liter. That gives me a 0.2 molar solution. So I already have my concentration, the right amount of concentration, to give me the 0.2 molar. So I take my 36 grams, whack them into 1 liter, and it has the right concentration. Slight problem. I don't want a 1 liter amount. I want only 150 milliliters. So, if I take 36 grams in 1 liter, I get 0.2 molar. If I take 36, how much would I need to use if I want 0.2 molar, but instead of 1 liter, I want 100 milliliter? How much would I have to use for that? Loud? 3.6. 36 grams in 1 liter, but I want only a tenth of that. So I take 3.6 grams. 3.6 grams in 100 milliliter gives me a 0.2 molar solution. Yeah? Actually, I don't want 100 millimolar, 100 milliliter. I want 150 milliliter. Bugger it. Oh, yeah. What do I do? Well, it would be 3.6 times 1.5, wouldn't it, in this case? So it would be 3.6 grams times 1.5. Whoops. 1.5, and that is 5.4 grams. Is that right? 5.4 grams. So it would go away, weigh in 5.4 grams of my substance, and put that into 150 milliliters, and I would have a 0.2 molar solution. This is probably the way you sort of have learned it at one point, where you calculated it step by step. Yeah? Okay, here comes Peter's magic. Let me just write down what we wanted. We said 150 milliliters, again 0.2 molar solution, and it has 180 gram per milliliter, per mole, sorry. That's the molecular weight, just to remind myself. Here comes the magic. And this magic is actually called dimensional analysis. I know I haven't done that with you because I think Dr. Foster did the molarity stuff with you guys. Yeah. Dimensional analysis, you don't have to learn any equations or something like that, because you are guided by the units of things. So, first thing is, what are we actually looking for? So, usually it says then, how many grams do you have to weigh in? To weigh in. So the first thing is, we are looking for the unit of what we are looking for. What's the unit that we are looking for? grams. We're looking for grams. We want to know how many grams we want to work in. So, first we write down the unit, gram. This is sort of, it reminds us that this is what we are looking for, the unit. And then we draw a big line, fraction line. It's always the same procedure. Now, in our givens that we have, so 150 milliliter here, 0.2 molar, 180 grams per mole, we ask, do we have any of these givens? Does this have the unit in it that we are looking for? Can you see that? Can you see a unit where we have that, or some of the givens? Which is that? 180 grams per mole, yeah? That is the guy that we have, that has our grams here. And we write it in such a way that the grams, that what we want, the unit that we want, is always on top of this fraction line. So we write 180 grams, and underneath the fraction line, in this case, is the mole. Per mole. Yeah? Have you used any equation so far? No. Excellent. Okay, so our gram, that is what we want. But this mole here, that's a little bit annoying. We want to get rid of that mole. Right. Do we have, from the remaining givens, do we have anything that has the unit mole in it? Out? Somebody's, I heard whispering here. Do we have anything that has the unit mole in it?
0.2.
We have the 0.2, and that stands for 0.2 mole per liter. Yeah? So this has the unit mole in it. Now what we do is, we use a really dirty trick, and we write this so that this mole here and this mole here cancel each other out. So we have a mole down here, so we write this here so that this mole is on top of the fraction line. 0.2 mole per liter. What happens to the moles if that was a fraction? They cancel each other out. Yee-hoo! We got rid of the mole. Unfortunately, we now have another problem. We have a liter down there. What can we do with the liter? Well, we want to get rid of it, so we want to cancel that out. So we can cancel that by saying, actually we have liter, the unit liter, in our last given. So that would be 150, and now I write it again so that the liter is on top, because I've got a liter down here. I want to cancel it out. 150 milli means what? What does the unit milli mean? 1,000? 1 over 1,000. Yes, exactly. So I write this as 150 times 10 to the minus 3 liter. 10 to the minus 3 means milli. Yeah? Right. Have you used any equation so far? No, not really. What happens to the liter? Yee-hoo! Hasta la vista. What's the unit that's left? Grams. Yes. What did we want? Grams. We're done. All we need to do now is put that together and say, okay, we have 180 grams times 0.2 times 150 times 10 to the minus 3, and that gives us the grams. End of chat. Let's see what you come up with. What do you get? 5.4. 5.4 grams. Easy. Let's do another one. I want you to make up 250 milliliters of 0.3 molar solution, and the molecular mass is 220 gram per mole. Let's see whether we can do that with this dimensional analysis. Do you want a couple of minutes to try it yourself first? Yeah? And then we do it together. Let's do the dimensional analysis together quickly. What are we looking for? Grams? Write that down. Write it always down at the beginning, because then you don't get confused. Do we have anything with grams in it? 220, and I'll write it so that the grams are on top, moles are on the bottom. We have the grams, okay, but the moles are annoying. Do we have anything with moles in it? Loud? 0.3 mole per liter. The mole cancel out. That's very convenient. And that's now just the annoying thing of the liter. Do we have anything with liter in it? 250, but we need to be careful. It is milliliter that we have. We can't cancel milliliter versus liter, so we have to write it as 10 to the minus 3. And now we can write liter. Liter cancels out, and that is what we want to calculate. So we have 220 grams. What's the unit? What is left in terms of unit? Grams, which we wanted. 220 grams times 0.3 times 250 times 10 to the minus 3 gives you 16.5. Yeah, that's approximately what I got. 16.5 what? Grams. Did you get that? Easy. Piss easy. Another one? Quickie? I want a 25 millimolar solution. I want 12.5 milliliter. And the molecular weight is 540 gram per mole. How much do I have to weigh in? Over to you. Let's do it together. What are we looking for? Grams, of course. Where do we have our gram unit? 540 gram and the mole underneath. Do we have anything with mole in it? Somebody to dictate what you want me to write? 25 times 10 to the minus 3. Yep. Mole per liter. Moles cancel out. Do we have anything with liter? Bless you.
0.5 times 10 to the 5.
Minus 3 liter. Liter cancels out. And all that's left is 540, bless you again, times 25 times 10 to the minus 3 times 12.5 times 10 to the minus 3 equals, anyone got something? 0.117 grams. How easy is that? Easier than the first method that I showed you. Yeah? Here's something for you guys. I have a 10 milliliter solution, and this is of a 0.2 molar concentration. And here it comes. How many moles are in there? Slightly different problem, isn't it? We haven't done that really. Can you come up with a strategy how to solve that? Remember what we've done in the last 20 minutes. Together? What are we looking for? What is the unit that we are looking for? Moles. Write that down. Moles. Fraction line. Do we have anything that has moles in it? 0.2 mole per liter. It's not good. Oh, what am I doing? Hang on. Yeah. Bugger. Hang on. You are requested to make up 100 milliliter of a 1% weight per volume solution of BSA, bovine serum albumin. The molecular weight of BSA is 66,000 gram per mole, or, because biochemists are lazy people, they just write this as 66 kilodalton. It's the same thing. How many grams do you have to weigh in?
What?
One. 1 gram. Why?
I think that's the definition of weight per volume. It's grams in 100 mils.
Did you get that? You're absolutely right. The definition of weight per volume is 1 gram in 100 milliliters. That is the definition of, well, percent weight per volume. So, we want to make 100 milliliters. We know the definition, 1 gram per 100 milliliters. So all we need to do is we have to weigh in 1 gram. But wait a moment, don't we have these 66 kilodalton here? What are we going to do with that? Any suggestions? What we do with this 66 kilodalton? Well, actually, this was information overkill. You're not doing anything with it. That was a red herring. Just to, confuse you. Sometimes you get more information than you bargain for. Doesn't matter. You just pick the one that is important to you. Does that make sense? If you have to make up a 5% solution, 100 milliliters, how much do you weigh in? 5 grams. Simples. Are you happy with that? Can you do these calculations now? I've got stuff on Facebook. I've uploaded some videos for you to look at that, how you can apply that. So I encourage you. I'll send around the link again for you to practice. Here's one more thing that I want to show you. And then you've basically covered all the eventualities that you come across in your project when it comes to making solutions. And that is dilutions. Let's say our challenge is we have a stock solution. The stock solution, let's say, is 100 millimolar. And we want to make, from this stock solution, we want to have 20 millimolar solution, 10 milliliter of that. How do I have to dilute, or what do I have to do? How much of my stock solution do I need? Does that look familiar? Does that look a challenge? I hope so. Challenge? Potentially? Easy. Can you vaguely remember this famous equation C1 V1 equals C2 V2? I hear some grunting. It sort of came back, flashback, bad flashback. It's too complicated for me. I can't deal with that because I always forget what is C1, what is V1, and all the other rubbish. Whenever I see that with a stock solution in it, I think of something completely different. I think of a guy that's me, who just came from the doctors. And the doctor gave this guy a prescription. And on his prescription it says, you have to take 10 milliliter of this 20 millimolar solution. So the doctor says, this is what you want. Where do you hand in your prescription? The pharmacist. So here is then the pharmacist. And the pharmacist says, I'm terribly sorry, we don't have 20 millimolar, but we have 100 millimolar. And this one here, that's the counter. Hey, and we are there. Because that is your equation. I want times I want divided by what we have. 10 times 20 is 200 divided by 100 equals 2 milliliter of the stock solution. This is how you deal with stock solutions. Forget C1, V1, all that crap. Just think of the pharmacist. I want, divided by what we have. Want another example? I have a stock of 100 milligram per milliliter. And I want to make 200 milliliter of 100 microgram per milliliter. How much do I have to use? Actually, this is a very, very common thing because you usually set up your antibiotics. If you have ampicillin, for example, for a culture, you usually have that as 100 milligram per milliliter stock. But your working concentration is 100 microgram per milliliter. So how would you do that? Well, very simple. We want. What do we want? What do we want? 200 milliliters times 100 microgram per milliliter divided by 100 milligram per milliliter. We need to be careful now because we have different units. But that is, in principle, our equation. So we can, for example, say, okay, a milligram is the same as 10 to the 3 micrograms. So we say 200 milliliter times 100 microgram per milliliter divided by 100 times 10 to the power of 3 micrograms per milliliter. Now the units, microgram per milliliter, cancel out. Even the 100 cancels out, very convenient. So all I have left is 200 milliliter divided by 1000, and that is 200 microliter. I want times I want divided by we have. Problem sorted. No fuss.